Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the early sessions, we were talking about attributes and sampling theory. In sampling theory, we are dealing with two types of samples. One is large sample and small sample. So, in continuance with the study of small sample when the sample size is less than or equal to 30, we have already seen a small sample test for single mean and difference of means. The objective of this session is to work out some problems in small sample test, that is t test for paired observations and t test for correlation coefficient. Interval estimation in this regard is also done. So, continuing with the t test for difference of means, the interval estimation problem is worked out as follows. Since this is interval estimation problem, we need not set up a null hypothesis, alternative hypothesis, etc. Solution. First of all, we will extract the information given in the question and into mathematical part. Two independent random samples of sizes 10 and 15 from two independent normal populations having variances 4 and 9 were found to have means 48 and 46 respectively. Find 95% confidence limits for the difference of the population means. So, here we will take sample 1, then sample 2 values. First of all, n1 size is 10 and here n2 is equal to 15. Sample variance is given, S1 square is equal to 4, S2 square is equal to 9, and then mean x1 bar is equal to 48, x2 bar is equal to 46. We have to find out 95% confidence limits for the difference of population means. So, the difference of population mean formula is given by t is equal to x1 bar minus x2 bar by s into root of 1 by n1 plus 1 by n2, where s is equal to root of, when the values are given directly, this is the formula, n1 s1 square plus n2 s2 square by n1 plus n2 minus 2. n1 is 10, right? Write down all the values from the tabular column. Now, 10 into 4 plus s2 square is 15 into 9, isn't it? 10 into 4 and 15 into 9 divided by 10 plus 15 minus 2, and this value happens to be 2.7583. This is S value. So, therefore, t is equal to x1 bar is 48 minus 46 by 2.7583 root of 1 by 10 minus 1 by 15. This is actually 1 by 10 plus 1 by 15. Now, this is actually t value, but we are calculating the 95% confidence limits, right. Therefore, here the t formula will have a slight change as minus mu1 minus mu2. Actually, this mu1 minus mu2 becomes 0 when you set up h0 as mu1 is equal to mu2. That is why this particular part is becoming 0 when you are applying the formula for testing the difference of means. Therefore, here also this mu1 minus mu2 will appear as it is, and this t stands for tabulated t at 5% comma degrees of freedom required. Degrees of freedom is 10 plus 15 minus 2. Okay. So, writing it neatly, to find 95% confidence limits only, no, confidence limits or confidence interval limits, 95% confidence limits limits t at 5 percentage comma 23 degrees of freedom is taken. 48 minus 46 is 2 minus of mu 1 minus mu 2. We are finding the estimate for the difference of this population mean only, divided by 1.126071. Okay. This table value we have to see from the tables. 23 degrees of freedom and 5 percentage level of significance is this particular value, 23 degrees of freedom and 5 percentage level of significance. So, this is 2.07. So, 2.07 into 1 minus 1.126071. Here you are having plus or minus because of the modulus is equal to 2 minus of mu 1 minus mu 2. So, therefore, mu 1 minus mu 2 is equal to 2 plus or minus 2.32984. Okay. Therefore, one value with a plus and another value with a minus. So, that is equal to 4.32984 and then negative is 0.32984. So, 95% confidence limits are 0.32984 and 4.32984. Next, students paired t-test for difference of means. This is also actually difference of means where you will be given two different types of samples. Now, sample is same, but they are different in the sense of before treatment and after treatment, as we were discussing in one of the previous sessions. So, paired observation in the sense the sample is same, but the sample will be taken before a kind of treatment and the same sample is considered after the treatment. So, it becomes a paired observations. T formula is given as T is equal to d bar divided by S by root n, where d bar is equal to summation d by n, where d is equal to difference between the two types of observations and S is equal to root of sigma d square by n minus d bar square. Now, set up H naught as mu 1 is equal to mu 2. This mu 1 and mu 2 is same because the population is same. Only thing the samples are different in the sense that they are treated as a population before treatment and they are another population, they are treated as another population after the treatment. They are just treated, but actually the sample is same. Only thing the treatment differs between the two types of samples and two types of populations. Okay. And H1 will be either mu 1 is less than mu 2 or and H1 will be mu 1 is greater than mu 2. Then step 3 is as usual level of significance part. Step 3 itself degrees of freedom is equal to n minus 1. N represents paired observations. Here one thing should be very clear, the sample size of first sample should be same as sample size of second sample. Like difference of means they should not be different here. So, paired observations are n means degrees of freedom is n minus 1. Step 4 is the formula part which I have written already, T is equal to d bar by S by root n. Then step 5 is a conclusion, usual step. Okay, this is the procedure for a paired t-test for difference of means. Now, we shall see this problem. An IQ test was administered to 5 persons before and after they were trained. The results are given below. IQ means an IQ test. Candidates are named as 1, 2, 3, 4, 5. The same 5 persons IQ is noted before training and the same 5 persons IQ is noted after training. So, their score is 110, 120, 123, 132, 125 and IQ after training is 120, 118, 125, 136 and 121. Test whether there is any change in IQ after the training program. Okay. So, you are asked to verify like whether the training program is effective or not. Okay. What is the sample size? The sample size is 5 in each case. Therefore, n is equal to 5 and this is to be done with paired observation. That is the identification we have done with this problem. Identification in the sense the sample is same and there are one set of sample before training and another set of sample after training. So, first of all let us start with H naught. H naught is step 1. H naught is mu 1 is equal to mu 2, that is there is no change in IQ before and after training program. And step 2 says H1 such that mu 2 is greater than mu 1, that is there is change in IQ, that is the IQ has improved so change in IQ after training. Then step 3 is your level of significance part. Level of significance is 5% and degrees of freedom is n minus 1. N is the number of observations, 5 set of observations is given, therefore 5 minus 1 is equal to 4. Step 4 is a t value, t is equal to d bar divided by s by root n. Okay. So, all this information is required. For that this tabular column will help you. This is x values, this is y, this is x minus y, d is equal to x minus y and this is d square. D square is equal to x minus y whole square. So, x is 110 and y is 120. So, 110 minus 120 is minus 10 and its square value is 100. Like that this tabular column and this tabular column are formed. So, what is the summation d here? Summation d is equal to minus 10, these values, and summation d square is equal to 140. First of all we have to calculate s, then we will calculate t. S is equal to root of summation d square by n minus d bar square, where again d bar is equal to summation d by n. Summation d is minus 10, so by 5 is minus 2. Therefore, S is equal to root of summation d square is 140 divided by 5 minus 2 whole square is equal to root of 24 equal to 4.898. Okay. Then t value will be d bar is minus 2 and s value is 4.898 divided by root of 5. So, 2 into root 5 gives you ultimate t value is minus 0.9130. So, now we have come to the conclusion step, comparison step. So, calculated t at 5% 4 degrees of freedom is given to be equal to modulus of minus 0.9130, which is 0.9130. Then tabulated t at 5% 4 degrees of freedom is equal to, we have to see from the tables, and this being a one tailed test, although it is 5%, we must look into 10% for 4 degrees of freedom. See 10%, because this is one tailed test, alternative hypothesis is one tailed. So, 10% and 4 degrees of freedom is 2.13. Okay. So, 4 degrees and 10%, this particular value 2.13 is written, 2.13. Now, calculated value is much lesser than tabulated value, therefore, H naught is accepted. Calculated value is less than tabulated value, hence H naught is accepted. Accepted in the sense there is no difference in IQ, there is no change. There is no change in IQ before and after training. There is no change in IQ of the persons before and after the training program. Next, after discussing t-test for single mean, t-test for difference of means and t-test for paired observations, the next continuance in discussion of t-test is t-test for testing the significance of an observed sample correlation coefficient. Now, if R is the observed sample correlation coefficient in a sample of n pairs of observations from a bivariate normal population, then the null hypothesis H naught is such that rho is equal to 0. R represents sample correlation coefficient, whereas rho represent population correlation coefficient. Now, we always take H naught as rho is equal to 0, that is population correlation coefficient is 0. It means the population is uncorrelated. So, population correlation coefficient is 0. The statistic formula is T is equal to R divided by root of 1 minus R square into root of n minus 2. Actually, the into root of n minus 2 should come in the denominator of the denominator. It has gone to the numerator. Therefore, the formula is R divided by root of 1 minus R square by root of n minus 2. That whole denominator stands for the standard error of the population correlation coefficient. Follows students t distribution with n minus 2 degrees of freedom. So, here almost the procedure also is given, that is you have to set up H naught as rho is equal to 0 against H1 appropriately, whether not equal to 0 or greater than 0 or lesser than 0. And then third step is level of significance and degrees of freedom part. The degrees of freedom is given by the formula n minus 2, and step 4 is the computation of the statistic given by the formula R divided by root of 1 minus R square into root of n minus 2. Now, we will do this problem. A coefficient of correlation of 0.6 is derived from a random sample of 27 pairs of observations. Is this value of R significant? So, what is the sample correlation coefficient value given? R is equal to 0.6 and n is equal to 27. How to identify? This is n is equal to 27 says that it is a small sample. Therefore, a t-test for correlation coefficient has to be used because you are asked to verify whether the value of R is significant. Set up H naught rho is equal to 0, that is the population is uncorrelated whereas the value of R is significant. Rho is uncorrelated where the value of R is not significant. So, the value of R is not significant. This is H naught. Then step 2, H1 part rho is not equal to 0, not equal to 0 in the sense the value of R is significant. Next step 3, level of significance is 5% and degrees of freedom is equal to n minus 2. Here n is 27, so 27 minus 2 is equal to 25. Next step 4, the formula part, T is equal to R into root of n minus 2 divided by root of 1 minus R square. R value is 0.6 into root of 27 minus 2 by root of 1 minus 0.6 whole square is equal to, the value is 3 divided by root of 0.64, the value is 3.75. So, the calculated value, we have come to the conclusion step. Calculated T at 5% comma 25 degrees of freedom is equal to 3.75, whereas tabulated T at 5% comma 25 degrees of freedom from the tables is 2.06. 25 degrees of freedom, 5% level of significance, the value is 2.06. 2.06. Then we see calculated value is greater than tabulated value. So, H naught is rejected. It means H1 is accepted, which says that the value of R in population is significant. Now, that said, with the discussion about t-test, in small samples we have seen t-test for difference of mean, t-test for single mean and paired t-test, and also t-test for sample correlation coefficient is also discussed. Next, in continuance with the small sample theory, next test is F-test for difference of variances. F-test is termed by the name R.A. Fisher. Okay. What does the F-test formula stands for? F is equal to capital S1 square by capital S2 square. This represent the estimates of the population variances. S1 square and S2 square represent estimates of the population variances. where this is the case when S1 square is greater than S2 square. Suppose if S2 square is greater, then the formula will become S2 square by S1 square, where you have S1 square is N1 S1 square by N1 minus 1 if the SDs are given directly. Directly in the sense the values are earlier calculated and it is given to you, and S2 square is equal to N2 S2 square by N2 minus 1 if the standard deviations are given directly. Otherwise, or capital S1 square is equal to summation x1 minus x1 bar whole square by N1 minus 1, and S2 square is equal to summation x2 minus x2 bar whole square by N2 minus 1. Now, this is the formula. What is H0, H1 etc. for F test procedure? F test procedure says that you should take H0 in step 1 as sigma 1 square is equal to sigma 2 square, in the sense that there is no difference between two population variances. Against H1, sigma 1 square is not equal to sigma 2 square. So, step 3 is level of significance part and degrees of freedom. Degrees of freedom will be N1 minus 1 comma N2 minus 1 if the formula of F is S1 square by S2 square, or the degrees of freedom will be N2 minus 1 comma N1 minus 1 if the formula is S2 square by S1 square. Okay. Now, step 4 is the formula part, and step 5 is conclusion. All the other steps are same. Conclusion step. We shall see this problem. In a sample of 10 observations from a normal population, the sum of squares of sample values from the sample mean is 100.4, and in another sample of 12 observations from another normal population, the sum of squares of deviations of sample values from the sample mean is 115.5. Test at 5% level whether the populations have the same variance. First of all, let us write down the values from the data given. Okay. So, N1 is equal to 10, and then summation x1 minus x1 bar square is 100.4. Similarly, N2 is equal to 12 and summation x2 minus x2 bar whole square is equal to 115.5. Okay. Then we have N2 is 15 and summation x2 minus x2 bar whole square is 115.5. Now, we go ahead with the F test procedure. First of all, H0 is sigma 1 square is equal to sigma 2 square. The two populations have the same variances. Two populations have same variance. Whereas H1 says sigma 1 square is not equal to sigma 2 square. Therefore, two populations do not have same variances. Okay. So, step 3, level of significance is 5% and degrees of freedom cannot be decided now. It has to be decided based on capital S1 square and capital S2 square, whichever greater should come in the numerator. Therefore, accordingly degrees of freedom formula is also will change. So, at present you leave this step as it is and then go ahead with calculating F value. So, capital S1 square, F is equal to S1 square or by S2 square or vice versa. Now, where S1 square is equal to summation x1 minus x1 bar whole square by N1 minus 1. So, which is equal to 100.4 by 10 minus 1, 100.4 by 9 is equal to 11.155. Okay. Similarly, S2 square will be summation x2 minus x2 bar whole square by N2 minus 1, which is equal to 115.5 divided by N2 minus 1 is 12 minus 1, which is 11. Okay. Now, this is equal to 10.5. Therefore, F value is S1 square by S2 square, which is 11.155 by 10.5. This value is 1.062. Now, degrees of freedom has to be filled up, which is N1 minus 1 comma N2 minus 1. N1 minus 1 is 9, 9 comma 11. Okay. Now write down the calculated f. So you have come to conclusion step. Calculated f at 5%, comma 9, comma 11 degrees of freedom is equal to 1.062, and tabulated f at 5%, comma 9, comma 11 degrees of freedom is from the tables, it is 3.10. Okay. So calculated value is lesser than tabulated value. H naught is accepted in the sense two populations have same variance, Now in this session some problems have been worked out in small sample t-test for paired observations and t-test for correlation coefficient. Interval estimation also is done. Also we have discussed the procedure for f-test. Based on the discussion in the session, the following questions are posed. Explain the procedure for f-test for difference of variance. Brief t-test for correlation coefficient. Thank you.